So methods of solving a first order. In our syllabus, we are only solving a differential equation of which order? First order only. Okay. So keep it in mind. We are only solving a differential equation of the first order only. Okay. So that's beyond that is not in our syllabus. So we only discuss first order. What is first order? If it is differentiated only one time, that becomes a first order derivative, and we're going to find the solution of that. Okay. So one of the method is variable separable approach. So maybe there's an example to show variable separable method. What is variable separable method is, if there is any way, I mean, this is one of the approach, it depends upon the question also. In case a first order differential equation is represented by dy by dx of f of xy. If f of xy can be expressed as a product of two functions of g of x and h of y, okay, where g of x is a function of x and h of y is a function of y. That means if we can separate the variables, then the differential equation is called variable separable type. For example, so when you can do that, we can first express the differential equation as product of the two different functions g of x into h of y, like this. After that, we can separate them by taking y on one side and x on the other side, and then we integrate on both the sides so that we get the equation in terms of y as well as x. Such a method is called variable separable method. Okay. And are we going to do this everywhere? No. Only in some questions where we can separate the variables, we can use this approach. Shall we check that? Yes. We'll check some example first. And then we can go to the questions. Please check this example. It will give a clear picture about how to solve a differential equation from a variable separable method. Yes. Let me explain this. The given question is first order only, right? We cannot, in our syllabus, we don't have second order or any higher order. It's only first order. And clearly they are told y is not equal to plus 2. Why, you know that, right? If it is equal to 2, what will happen? It will have a 0 in the denominator. Now we have to do variable separable approach. Is it possible to separate them? Yes. I can rearrange this equation as 2 into y into dy is equal to x plus 3 into dx. Now integrating both the sides of the equation, we get integral of 2 minus y with respect to y. Here integration of x plus 3 with respect to x. Okay, we have to, if we are differentiating, integrating one time, we need to get the arbitrary constant only one time, right? So that is why you can write 2y minus y square by 2 is equal to x square by 2 plus 3x plus a constant c. Okay. Further, if you simplify, we get, what do we get? So it's going to be 2y. If we can simplify this further, x square plus y square by 2, yes, plus 3x plus 2c, maybe I'll write c1 is equal to 2y, right? Further, if you simplify, what do we get is, I'm going to write it here, x square plus y square plus 6x minus 4y plus 2c1 equal to 0. Am I right? Yes, this 2c1 can be further written as a random constant c. Okay. Yes, this is the general equation. Why it is called general equation? Because I don't know what is c. How will you find c? By knowing the value of x and y, we can find c. As we don't know the value of x and y, I can stop at this part and I call it as a general solution because I don't know the value of c. Am I right? Is it clear to you? Yes. let's take another example. Find the particular solution of the differential equation. Again, it's first order. I'm repeatedly telling that you will not be asked to solve a second order derivative or any higher order. So at now see, this question is specifically asking at y is equal to 1, x is equal to 0. As we have a particular variable to substitute here, we may end up with a particular solution. But for finding a particular solution, so what we need to know first, find the general solution. How to find the general solution? Again, variable separable approach only we are discussing it. So given equation dy by dx is equal to minus 6x into y square. So let us rearrange this. Dy is equal to minus 6 into x into dx. Okay, so it is y square, right? So which is y power minus 2 into dy plus 6x into dx equal to 0. Am I right? Now integrate the equation on both the side. Then it is y square y power minus 2 dy plus integration of 6x dx is equal to integration of 0. So it will be y power minus 2 plus 1 by minus 2 plus 1 plus 6 into x square by 2 plus a constant equal to 0. Right? So what do we get is minus 1 by y. Right? Am I right? Yes. Plus 3x square plus c equal to 0. Now I want to find the c because we want a particular solution. So let us substitute x is equal to 0, y is equal to 1. What do we get is minus 1 by 1 plus 0 is equal to c. So c is equal to how much? Minus 1. As c is equal to minus 1, what is our particular solution? Our particular solution will be now, what is it? This is the equation we have got. So y is equal to 1 by 3x square minus of minus become plus. This is our equation, so particular solution. So do you understand the difference between particular as well as general solution now? Yes. Let me erase this part. Now let's solve some questions, shall we? By variable separable method. Yes. There are 5 questions. Let's solve them one by one. Yes. Yes. Solve this equation. So we have learned only one method. So all this question must be solvable by variable separable method only. Okay. So let me write it as root of 1 minus y square minus m because I took it on the right side. So now what I'm going to do is I'm going to separate them like this is equal to minus dx by root of 1 minus x square. Let me bring all of them on one side of the equation. That's left side. 1 by root of 1 minus x square dx equal to 0. Now integrate on both sides. What we get is dy by 1 minus 1 y square plus dx of 1 minus x square is equal to integral of some 0. So what I get is sine inverse of y. Do you remember? Yes. Plus sine inverse of x is equal to some constant. We don't know the particular solution because we don't know what is x and y. So the answer is simply sine inverse of y plus sine inverse of x equal to 0. Shall we check the answer? Yes. It's not equal to 0. It is equal to a constant c. What is c? We have to define always. C is defined as a c is an arbitrary constant. Remember that c is an arbitrary constant. Fine? Yes. Let me erase this. So let's go for the next one. Yes. Now again, variable separable approach only we are going to do. dy by dx is given by what? xy by y, xy by x. Is it possible to separate the variables first? Y separate and x separate. Can we do that? So let me take y common here. I'll get x plus 1. Here x common here, I get y plus 1. Now, which can be written as y divided by y plus 1 into x plus 1 by x is equal to dy by dx. So we should be very careful. So there are many ways to solve it, but there should be a smart way to get this right and faster. So what I'm going to do is I'm going to keep dy there itself. So and bring the y part here. It is y plus 1 by y is equal to x plus 1 by x into dx. So now if we integrate on both sides, what we get is integrate of 1 plus 1 by y dy is equal to integrate of 1 plus 1 by x of dx, isn't it? So what we get finally? Y plus log y is equal to x plus log x plus some constant, say let it be written in the log k. Okay, I'll tell you why. So now what happens is y minus x equal to, let me write it like this, y minus x equal to logarithm of x uh, into k minus logarithm of y. Okay, now what I'm going to write is y minus x equal to logarithm of kx by y. Why? Because we know logarithm of a into b is equal to log a plus log b. Similarly, log a minus log b is equal to what? Logarithm of a by b. That's what I'm using. So finally, I have want y only here, which is x plus logarithm of k times x by y. That's your answer. Let's see how they have ended the solution here, shall we? Yes. Yes, the same thing. Y minus x is equal to log of kx by y. Right? And in all these logarithms we write, the base of the logarithm is what? E. That is exponential constant. Remember that? Okay, it might be required somewhere because we are talking about the particular solution, right? When we talk about particular solution, we may have to understand it has to be logarithm to the base E. Okay, so let me erase this quickly. Right. Every question solved in the revision class is equal to every question practiced, right? So please, I am having this patient to solve every question here. So we also have enough time for this topic, luckily. So we are trying to solve each of them without any hurry. Okay. Now how to solve this one? Please think about it. Give me the strategy. Can we do the variable separable method? Let's see. Just let me separate the variables and see. Y divided by 1 plus y square into dy is equal to 1 plus x square. Let me keep this separately. Plus x divided by 1 plus x square. Entire thing divided by x into dx. That's what I'm writing. Okay. Now let us assume 1 plus y square as t. Then 2y dy is equal to dt. The left hand side equation is just sorted by substitution. Right hand side, what happens is this becomes now dt by t integral is equal to, we are dividing them individually, 1 plus x by x square into 1 by x dx. Are you understanding? So this is also integrated now. So this is logarithm of t plus This is 1 by 2, right? So dy y is actually dt by 2. So it's 1 by 2 logarithm of t, which is equal to, if we are taking this, it is 1 by x dx plus integral of 1 by 1 plus x square dx. So it is 1 by 2 times logarithm of t, which is equal to logarithm of x. T can be replaced by what now? 1 plus y square, remember, yes. Is equal to plus tan inverse of x, am I right? Plus c. The c, maybe we can keep it in log if you want. So somehow this is the answer. Let's see what is the actual answer at the end, how they have simplified. Shall we check? Yes. Yes, they stopped it here. 1 by 2 logarithm of 1 by y whole square. 1 by square is equal to log x plus tan inverse of x plus c. Yes, it is matched. It's matching with our answer as well. Can you see that exact answer? No change. 1 by 2 logarithm of 1 plus y square is equal to log x plus tan inverse of x plus c. Isn't it good to see our solutions are exactly matching with the given solution? Yes. That happens only if you follow all the steps strictly. Okay. Let me erase this. Let me go to the next question. Question number 4. Variable separable approach. Y into secant square x plus y plus 7 into tan x dy by dx equal to 0. So can we separate the variables first? Let's see. Can we take y common? First y into, let me rewrite. Let me write it as y common. If you take, what will happen is secant square x minus tan square x, tan x, right? Let's first separate them. Let's keep the equation outside. I mean, let's separate the variables on the right hand side if we have 0, right? So it's easy for us. As long as we have 0 on the right hand side, we can move it easily on the other side. Equal to minus y plus 7 into tan x, yes, dy by dx. So now what happens is y by cos square x, can I write? Yes, is equal to minus y plus 7 into sin x by cos x into dy by dx. So 1 cos x cancels with this. Very good. So now I'm going to keep the variable like this. Let me rearrange this. Y plus 7 divided by y dy. Am I right? Is equal to, I'm bringing the sin x this side. That is, what will happen to this? 1 by sin x cos x. Am I right? Yes. It will be dx. Isn't it right? Yes. So what else we can do? Let's see the solution part quickly so that we can get the answer faster. So yes, there can be a substitution. All that we know how to substitute and all, right. So what they have done, let me erase this part first. So yeah, so integrating on both the side, we have got secant square x by tan x. Yeah, so you don't have to remove them. You can keep the secant square x and tan x as it is. It will be even easier. So what we can do here is let the secant square x be there as it is. Y into secant square x is equal to, it was already easy for us, right? So y plus 7 into tan x dy by dx, right? Now what I'm going to do here is secant square x, let it be there. Let me bring this dx upside, divide by tan x. So variable separable method plus y by 7 by y. Am I right? Yes, dy equal to 0. This is what it is. Now integrate, what we get is So let tan x be t. Then this will be 1 by t. So it is simply logarithm of tan x, yes, plus y plus 7 log y is equal to sum log k. Maybe if I write. So then y is equal to logarithm of k into y power 7 divided by tan x plus some constant. Something like this will be the answer. Let's see the answer, shall we? Yes, see, they have brought they have even brought this exponential constant. You don't have to give the exponential constant. In case if you want to write it in exponential constant format, we can write it as well. Okay. Yes. This is our concept now. Homogeneous differential equations. What do you mean by homogeneous differential equations? So suppose if the variables are together and the powers of the variables, product of the variables are equal to 1, that becomes homogeneous in simple way. See here, what is the highest power of y? 2. And if you have x and y mixed, even the total power sum is 2. That is called homogeneous. It's a linear with a 1 degree. Here sin x and sin y. So we have sin x and sin y with the same degree. So it is still linear, and it's not linear, but the power is still same. That's called homogeneous. Okay. So even that can be, we can easily separate. So let's look at some examples of homogeneous differential equation, how they have solved it. There is nothing like you have to solve it. There is mostly proof we have to show. For example, there is a question here. Can you check the question? You have to prove that x minus y into dy by dx, yes, is equal to x plus 2y is a homogeneous one, and solve it. This is a homogeneous one. You have to show this first. Okay. And you have to solve it. How will you show this is first? If you rearrange this, dy by dx is equal to what we get. So x plus 2y by, x minus y. Is it clear? So now if you want to show this, you have to give this function as gy by gx, right? So this is, you divide the numerator by x, denominator by x. So what we have get is 1 into 2y by x, 1 minus y by x. So if you replace y by x by some variable, so it will become simply 1 plus 2t by 1 minus t. And yes, this become a homogeneous equation, right? Yes. So yes, now what happens is y can be written as t into x. And we can differentiate this with respect to x. Dy by dx is equal to what? Using our product rule. Do you remember product rule? Yes, we are using the product rule. So check the way it is being done here with the product rule. This is another way to solve a differential equation. So if we differentiate with respect to x, we can write v plus x into dv by dx, substituting the dy by dx on both the side. What we get here, see. So yeah, so this will take a little good time, but still it's easy to solve this way. Suppose if whenever you have a homogeneous differential equation, we can convert into some other format. So like here they have taken v, I have taken t. Let me erase this and show you here itself. So we can have this equation now, v plus x into dv by dx. That's product rule, 1 plus 2v by 1 minus v. Now we have to separate this. So what happens here is x into dv by dx is equal to 1 plus 2v by 1 minus v minus v. So after that we have separated the variables. So we'll keep, now what will you do is we'll keep dv here and we'll bring entire expression here like what we do in the variable separable approach. And here we'll be having 1 by x and dx, then integrate. And finally, whatever the answer we are getting, we have to put it back in the form of y, not in terms of v. Okay, it's a long process. You can check all these steps here. So with a limited time, I'm just showing the solution part here. So please remember this, whenever you're not able to separate the variables directly, like we did in the variable separable approach, we're going to use this if it is a homogeneous differential equation. Then we will write that as some function of y by x or f of t, and replace that y by x by t or v, whatever, and you differentiate. Finally, we end up with differential equations. But it is a little longer process, as you can see here in this example itself. But still, it is not a difficult one. Only it's a lengthy process. At the end, if you are good with integration and differentiation, you will not be having any trouble even in getting this solution, because we have solved very peculiar and difficult questions in integration. So this is nothing. We have the formula, we know the format, we know how to differentiate and integrate all the types of functions so far, which is in our syllabus, so that it is not going to be difficult one. Only thing is you should be perfect with what is being learned in the integration class. Okay, that comes by practice, as I say. Okay, let's come to the last part of this class, which is, what is it? Another method for a linear differential equation. Okay, yes, very good. I can see that comment in the chat. So most of you are being studious. You know what is the next topic as well. Yes, is linear differential equations. This is a very peculiar approach to solve a differential equation. So please pay attention. If you have confusion in your regular classes, please observe here. I have given a very simple approach to solve linear differential equations, and we have some examples as well. A linear polynomial equation, which is made up of derivatives of many variables, is known as a linear differential equation. When the derivatives are partial and the function depends on the variables, it is also expressed as a linear partial differential equation. But let us not worry about partial differential equations right now. Okay, so that's not in our syllabus anymore. So let's only worry about the linear differential equation, a complete linear differential equation. So it is like this. If whenever you have a dy by dx plus some p into y is equal to q, where p and q are either arbitrary constant or the variables are the functions of the variables which are independent of y. Okay, independent variables. Then it can be a variable of x, z, anything apart from y, because y is a dependent variable, or it can be a constant also. Such a differential equation is called linear differential equation. So let's see how to solve them. So whenever you have a linear differential equation of the form dy by dx plus py is equal to q, you have to figure out the entire equation. All the steps are here, but we have a shortcut after this. Just observe what is the actual reason behind the shortcut. Multiply the above equation by another independent function of the variable g of x. So when you multiply, what you get is dy by dx plus p into g of x into y is equal to q into g of x. What is the g of x? We have to choose this g of x in such a manner that LHS becomes RHS. Okay, so we cannot randomly choose any. That is the biggest task, but there is a shortcut for us. I'll tell you. So further, if you solve this, what we get here is we are going to write it as d by dx of y into g of x. So all these steps you can check, but I'll go to the direct approach for this. Okay, so whenever we have a linear differential equations of the form dy by dx plus p of y is equal to q, we have to find p. Okay, that p, we have to find something called integration function or integral function factor, integrating factor, which is of the form e power p times dx. It's called integral factor. With the integral factor, what we're going to do is we're going to multiply that integral factor with y like this, which will be equal to integration of q into integral factor with respect to x plus c. That will give you the differential equation solution. Please remember how to find integral factor. Integral factor is e power integral of dx into p. It's p into dx. So we have to be very careful to understand what is p, what is q. What is p and q? P and q are either arbitrary constants or variables which are independent from the given differential equation, either in terms of x, z, whatever. So in that case, we are going to solve the entire integral function with this format: y into integration factor or integrating factor is equal to integral of q into integral factor plus c. And what is that integral factor? Integrating factor is e power p dx. So this much is enough. If this much knowledge is enough for us. Okay, why, how? We don't have time for that right now. So let's just follow these steps carefully in solving the question. Shall we solve some questions quickly? Yes, let's take an example first, a solved example, and after that we can go for a question. Yes. First, we have to check whether the given equation is a linear differential equation or not. Check this. Yes. So we'll simplify this by dividing the entire equation by x first. So then we'll have only dy by dx separately. So it is 2 into 1 by x into y is equal to x. Now this is of the form dy by dx plus py is equal to q. So what is p here? 2 by x. What is q here? X. Now what is our integrating factor? Integrating factor is e power p dx. So what is e power integral of 2 by x dx, which is e power logarithm of 2 log x, which is e power logarithm of x square, which is actually x square. Why? Because e power logarithm to the base of e will be always equal to that number. So it is x square. So integrating factor is simply x square. Now what is our approach? We will multiply the y into integrating factor is equal to integration of q into integrating factor into dx plus c. Yes or no? Now y as it is, what is integrating factor? X square, which is equal to integration of what is q here? Q is already x, and then x square into dx plus a constant. So which is y is x square is equal to x cube. Integrating that will become x power 4 by 4 plus c. So we have to bring this x square this side to have y on one side, which is x square by 4 plus c by x square. This is our final equation. I hope this part is clear. Let us take some examples quickly. Shall we? Yes. They are asking only integrating factor here. So what is the integrating factor for this question? Shall we see? X into, isn't it similar to the question we saw here? Yes, there's a small change in the only one part of the equation. So that's why the answer may vary a little. Okay, I'll tell you why. So it is x into dy by dx minus y is equal to 2x square. Divide the equation by x on all the side, we get dy by dx plus y into minus 1 by x is equal to 2x. Now it is compared with dy by dx plus py is equal to q. Our integrating factor is e power p dx. So what is p here? P is minus 1 by x. So what we get is e power integral of minus 1 by x dx, which is e power integral of minus 1 by x dx. What we get? E power minus log x. So which is simply x power e power logarithm of x power minus 1, which is x power minus 1, which is also equal to 1 by x. Then what is our integral factor? Integrating factor is simply 1 by x, isn't it? Shall we check the answer? Yes, see, finally we have got 1 by x. Yes. So let's take one last question in this part. So it's very repetitive. If you solve more and more questions, you can remember them. So we just have to find the solution of this question. With this, we can wind up x into dy by dx plus y is equal to e power x. So let's rearrange this equation first. Dy by dx plus y by x is equal to e power x by x. Okay, so it is of the form dy by dx plus py is equal to q. What is p here? 1 by x. Q is what? E power x by x. Okay, so our integrating factor is e power integral of p is actually how much? 1 by x dx. So which is e power log x. So this will become x. Yes or no? So our answer will be y into integrating factor is equal to integral of q into integrating factor into dx plus a constant. So y into x equal to integral of what is q? E power x by x into x plus c. So this will anyway cancel. So we end up with y is equal to e power x plus c. That is our equation. So let's see, is this the answer for us? Yes, e power x by k by x. Why it is like this? It's because we have x here. Yeah, after solving all this only we can get right. Yeah, small correction here. This is all right. So once you get this, after that only we have to divide by x. So if you take k or x, c, it will become y is equal to e power x by x plus c by x. This is our solution. Yes. So with this, we have come to the end of calculus in our 12th mathematics.